Hello students, how are you all doing? Hope that you must be fit and well. Today we are doing a sum from JEE Advanced paper 2016. The sum reads like this. Let A be element of R and F maps R to R be defined by fx equals to A cos modulus of x cube minus x plus b into modulus of x into sine modulus of x cube plus x. Then f is a differentiable at x equals to 0 if a is equals to 0 and b equals to 0. B differentiable at x equals to 1 if a is equals to 1 and b is equals to 0. Not differentiable at x equals to 0 if a is equals to 1 and b is equals to 0. Not differentiable at x equals to 1 if a is equals to 1 and b is equals to 1. And it is being told to us that out of these four given options for the answer of this question, there may be more than one option correct, and we have to find all the correct options for the given question. Okay, now see here. Okay, we have to check the differentiability of this function at x equals to 0 and x equals to 1 for these values of a and b given. Okay, now see here. Here the function fx is given as a cos of modulus of x cube minus x, okay, plus b modulus of x into sine of modulus of x cube plus x, okay, plus x. Okay, now see here, and here it is being told to us that a and b are elements of real number. Okay, so here a and b are element of real number, correct? Now see here, so what we have to check its differentiability at points 0 and 1. Now see, I am breaking this full function into the sum of the two functions. Okay, so I am assuming that this is y1. Okay, so y1 is equals to a cos of modulus of x cube minus x. Okay, and this function as the y2. Okay, so y2 is equals to b into modulus of x into sine of modulus of x cube plus x. Okay, now so here fx will be what then? Then fx will be equals to y1 plus y2. Okay, now see here. Now when x cube minus x is less than 0, that means this value x cube minus x is less than 0. Okay, so in that case, what will be the modulus of that? So the modulus of then x cube minus x will be equals to negative of this, because this is negative number, so its modulus is always positive, so it will be negative of x cube minus x. Its modulus will be like this. Okay, so in now, so therefore what will be y1? So y1 will be here, this will be negative. Okay, so this will be a cos, okay, negative of this x cube minus x. Okay, it's negative of that because this is negative number. Okay, so modulus is always positive, so it's negative of this. And what we know? We know that cos of minus theta is equals to cos theta. So this value y1 will be equals to a cos of x cube minus x, because cos of minus theta is equals to cos theta. Okay, now when okay, x cube minus x is greater or equals to 0, that means this number is a positive number. Okay, so the modulus of a positive number is the same number. Okay, so the modulus of x cube minus x will be equals to x cube minus x in that case. Okay, so y1 will be what then? Y1 will be a cos of this modulus, this will be same as x cube minus x. So this will become x cube minus x. So what we are noticing, that whatever may be the value of x cube minus x, whether x cube minus x is less than equals to 0 or less than 0 or greater or equals to 0, y1 is always equals to a cos x cube minus x, that is free from the modulus. Okay, now let us check for the y2. Okay, so now we are checking for y2. Okay, that is the second part of the function. Okay, now see here. So what we will have now here, y2 is equals to, okay, b modulus of, okay, modulus of x into sine of modulus of x cube plus x. Okay, now let us when x is less than 0, so in that case, when x is less than 0, so x cube plus, so in that case x cube plus x will be also less than 0. Okay, so modulus of x in that case, when x is less than 0, so modulus of x will be equals to minus of x, and modulus of x cube plus x. Okay, this is also less than 0, so its modulus will be minus of this number x cube plus x. Okay, now so y2 will be what then in that case? So y2 will be here, its modulus will be minus x. Okay, so this will be b into minus x, and its modulus will be also negative of this. Okay, so it will be sine of minus of x cube plus x. Okay, now we know that sine of minus theta is equals to minus sine theta. Okay, that is sine of minus theta is equals to minus of sine theta. Okay, so this will be y2 will be equals to minus bx into, here sine of minus this will be minus of sine x cube plus x. Okay, so minus into minus become plus, so y2 is equals to bx into sine of x cube plus x. Okay, now when x is, okay, when x value is greater or equals to 0, in that case what we will have? In that case the modulus of x will be equals to x, because this is positive number, x is greater or equals to 0, so modulus of positive number is the same number. And in that case, when x is greater or equals to 0, in that case x cube plus x will be also equals to greater or equals to 0. So its modulus will be also, this will be a positive number, and the modulus of positive number is the same number. So the modulus of x cube plus x will be equals to the same number, x cube plus x. Okay, so y2 will be what in that case? When x is greater or equals to 0, so the modulus of x will be equals to x in that case. Okay, so this will be bx, and sine and the modulus of x cube plus x will be equals to same number. Okay, so x cube plus x, because this is positive number. So in what we are noticing, so we are noticing that whatever may be the case, whether x is less or equals to 0, less than 0 or greater or equals to 0, y2 is always bx sine x cube plus x, that is free from the modulus sign. So this is a even function. So fx is a even function in that case. Okay, so we get that y. Okay, so what we are having in that case, so fx in that case is always free from the modulus sign. It always equals to a cos, okay, x cube minus x plus bx, okay, sine of x cube plus x, that is always free from the modulus sign. And we know that the cos function is continuous and differentiable everywhere. Cos function is continuous and differentiable everywhere. Sine function is continuous and differentiable everywhere. and x is the identity function. It is also continuous and differentiable everywhere. Okay, for all real numbers. So identity function into a sine function will be always continuous and differentiable, and cos is also continuous and differentiable everywhere. So the sum of the two continuous functions, okay, will be always, so the sum of this is continuous, this is continuous, so the sum of the two continuous function is always continuous and they will be always differentiable. Okay, so for all values of a and b, so the fx, so therefore fx will be differentiable at x equals to 0 and x equals to 1, whatever may be the values of a and b. So the options a and b are correct. Okay, and the option C and D are telling they are not differentiable. No, they are differentiable everywhere. Okay, because this is the even function. Okay, so the options A and B are correct. Okay, and C and D are wrong. Okay, so I hope that you must have understood the sum very clearly. Okay, thanks for watching the video. Stay fine. Thank you.